Hello, this is the practice exam for unit number 2. So I'm going to just jump right into it. The first section here is all concepts from the different sets of notes that you've done. The three things to look through for this are the Intro to Matter notes and the set of notes on Alchemy, and also that worksheet that we did on density. There were some sort of big ideas from that I want you to look through and just make sure you have a pretty good understanding of the big ideas for all of that. So this first question is asking about states of matter. The ones that you need to focus on are solid, liquid, and gas, but don't forget that plasma exists out there and that it's a fourth state of matter, and that when things get heated beyond a gas, that they become a plasma. I think that's an important thing from this unit. The first one, just directly from the notes, it asks solid substances, how is their volume and how is their shape? Like, is it a definite or does it change over time? And solids have a definite shape and a definite volume. So what that means is their volume and their shape stay the same, regardless of the container that you'd put them in. So that, as I said, just directly from the notes. So kind of look through, make sure that you know how those work for the different things. Picture at the right, this is another state of matter question. You can see here that the particles are spread out and they're kind of bouncing around the container here. That indicates to me that it is a gas. Vitamin C here, so we're doing a classification of matter. Vitamin C, you can see it has a formula there. That means it's a pure substance. It has more than one capital letter in its formula, so it has more than one element in it, which makes it a compound. So next one, Gatorade. Gatorade does not have a formula. That means we're talking about a mixture. If you're drinking Gatorade, the hope is that the first drink of Gatorade will be just like the last drink of Gatorade, which means it will be the same throughout. I haven't told you it's a colloid here, so you're just going to assume that it's not a colloid, and so that means that we're going to go with homogeneous mixture, the same throughout. Marshmallows, I tell you, are a colloid. That's an example of a heterogeneous mixture. All colloids are heterogeneous. The idea here with marshmallows is there are some different chemicals in them that when they form the marshmallow, some chunks are slightly different than other chunks. With marshmallows, what it is like the way that the gelatin forms into some little bits, and so it's actually not quite the same throughout, even though you might look at it and it looks the same, because it's a colloid, because I've told you it's a colloid, you know that it's heterogeneous. So remember, all colloids are heterogeneous mixtures, and then alloys, I didn't mention alloys here, but all alloys are homogeneous mixtures. Tin, which is chemical symbol SN, there are a couple ways that you can figure this out, but it is an element. The first way that you can figure this out is I've given you the formula there. SN is the formula. It only has one capital letter in it. That means it's an element. The other thing is, if you look at the periodic table, you'll see that tin is on there. That SN is on the periodic table. And so you know that the periodic table only contains the elements. And so that's another way that you can think of it. Number 7, it says the picture to the right most likely shows what? This one here. What you see there is substances that have multiple elements in them, because you can see there are big circles and small circles like the red and the blue ones, all right? So there are different things in here. So we know it's not an element, because if it was an element, all of the circles would be the same. There'd be only one kind of atom. There are multiple kinds of atoms in here. But they're all chemically combined in the same way, which means we have substances that are the same. There's like a pure substance. They're the same thing. And so we know here then it would be a compound. What you would see if it was a mixture would be some different stuff in there. So there would be not only something that looks kind of like what we're looking at here, but maybe some individual circles by themselves, or some other chemicals that are bonded differently or something along those lines. And so since all of these kind of look like each other, we know that it is a compound. It's a pure substance and it's a compound. Distillation, this is just, making sure that you know your different separation techniques. Distillation separates based on boiling points, all right? And if you want more information on that, there's a section of the review, so you can watch that video later, and that will give you a little bit more information about distillation and the other methods of separation. Density of an object, it's a property because properties describe, all right? So a chemical change, something would change, all right? Nothing. When I say density, nothing's changing when I say the word density. It's something that's describing an object, and it's a physical property because you can measure the density without chemically interacting with the object or without causing a chemical reaction to occur with the object. Chemical properties, you have to have some sort of chemical reaction occur to detect them. So density is not one of those. For density, you just measure the mass, you measure the volume. You don't have to chemically react to anything there, and then you can calculate that. Bubbling and fizzing is evidence of a chemical change. There are 5 or 6 different things listed in your notes that are evidence of a chemical change, so make sure that you're familiar with those. Melting an object is an example of a physical change. Now, the reason that this one is a change is because melting is the process of going from a solid to a liquid. All right, so something's changing here. We're going from a solid to a liquid. It's a physical change because when something melts, it actually stays the same chemical that it is. So for instance, if you have ice and you melt it and it becomes liquid water, ice is frozen H2O, liquid water is liquid H2O, but we haven't chemically changed what it is. It's frozen water, it's just liquid water, okay? So no chemical reaction has occurred, no chemical change has occurred. If there's a chemical change, you get new chemicals in the end, different from what you started out with. So boiling, this is a common misconception people have, but boiling and freezing and melting and condensing, all of those things are chemical changes. No, sorry, physical changes. All of those things are physical changes because they don't change what a substance is. They just change its state of matter. Going to the questions here on the back, these are from the notes on the alchemy. So it says the process of turning one element into another is known as, this one is called transmutation. That's directly from your notes. Greco-Roman alchemy was centered in which city? It's Alexandria. During the Renaissance, alchemists came to be mostly seen as thieves and tricksters. All right, again, that's all in the notes. And if you're struggling with that, I've posted a PowerPoint video on the YouTube channel where you can see me describe all of those things in regard to the alchemy and things like that. So if you want to brush up on that, you can watch that video. Carbon tetrachloride here says is a liquid with a density of around 1.56 grams per milliliter. Looking at the density table below, which of the following substances would float in carbon tetrachloride? And it says select all that would float. So you have to maybe select multiple ones here. The rule of thumb, something will float if it has a density less than the liquid that it's submerged in. Carbon tetrachloride, we've said the density is 1.56 grams per milliliter. So if it's going to float, we're looking at things that have a density of less than 1.56. Gold, its density is 19.3, so gold is not going to float. 19.3 is much more than 1.56. Cherry wood, 0.43. 0.43 is less than 1.56, so cherry wood would float. Aluminum, 2.7. 2.7 is more than 1.56, so aluminum's not going to float. The rubber here, rubber's 1.50. That would float. All right, so that's how that one works. Okay, going down here to the density problems on the bottom, it says, what would be the volume of 400 grams of platinum? So in order to do this, you need to use the little algebra circle that we drew up in class. It looks like this. All right, density is mass over volume. Okay, you got to remember this, and what you do is you just cover up the letter of the thing that you want to solve for. I'm asking for the volume, so if you cover up the volume, what you get is m over d. All right, volume equals mass over density. All right, and to use that one then, we're going to say 400 is the mass here, over the density of platinum, 21.45. All right, and if you calculate that, you should get 18.6, all right, which is answer D. And then this was in milliliters because volume is either going to be in milliliters or centimeters cubed, because those are kind of the general ones that I'm using here. Important to note that a milliliter and a centimeter cubed are the same thing, because on this next problem here, actually, we're going to use that directly. So 17 says, what's the mass of 1,000 centimeter cubes of a 1,000 centimeter cube statue which is made of oak? So for 17, we cover up, in this case it's asking for the mass, so we cover up m. We get m equals d times v. Okay, the density of oak is 0.85, which is equal to, 0.85 times the volume, which is 1,000 centimeters cubed. All right. And so here, even though the density was given in grams per milliliter and we had a volume in centimeters cubed, because they're the same thing, a centimeter cubed is a milliliter, we can just use them interchangeably. We just throw that right in here, 1,000 for that. All right, and then we multiply it, we get 850. All right, and the units on that, since it's mass, would be grams. All right, so we find that A is 850 grams. All right, on this last one here, we've got a substance is given us the mass and it's given us the volume. It asks us to identify the substance. So we're going to calculate the density here. You get density equals mass over volume, which in this case equals 2625 over 250. All right, you calculate that and you get that density equals 10.5 grams per milliliter or grams per centimeter cubed. If we look up at the list up here, 10.5 goes along with silver. So it looks like this substance is silver. When you look at the list here, mahogany, titanium, gold, and aluminum, silver's not there, so we would circle none of these. Okay, so that was a pretty quick explanation of what was going on with this practice exam. As I said, if you'd like to review further, look at the review. A video of that should be posted here shortly. Otherwise, just stop in if you have any questions.